Hi everyone. Today we're going to study properties of Laplace transforms. First is when we have the sum of two functions and we want to take the Laplace of such. This is equal to Laplace of the first function f of t plus Laplace transform of the second function g of t. Second, if when we have constant multiplied by the function f of t, and we want to take the Laplace transform of this. This is equal to the constant c multiplied by the Laplace transform of f of t. Third, when we have the first derivative of the function with respect to t, and the Laplace transform will be s times the Laplace transform of the function f of t minus f of 0. Fourth is the second derivative with respect to t, and we want to take the Laplace transform. This is equal to s squared times Laplace transform of f of t minus s times f of 0 minus f prime of 0. Fifth is when we have third derivative with respect to t, and we take the Laplace transform. This is equal to s cubed times Laplace transform of f of t minus s squared times f of 0 minus s times f prime of 0 minus f double prime of 0. Sixth is when we have the function t raised to n multiplied by f of t, and we want the Laplace transform. This is equal to the negative 1 that is raised to the power n, and this is the nth derivative of Laplace transform of f of t with respect to s, where n is equal to 1, 2, 3, and so on. So example, when we have Laplace transform of t times f of t, this is equal to the negative of d over ds of Laplace transform of f of t. Another example, when we have Laplace transform of t squared times f of t, this is equal to second derivative of Laplace transform of f of t with respect to s. Example 1, find Laplace transform of the product t times sine at. By property number 6, this is equal to negative of derivative of Laplace transform of the sine at with respect to s. Then we simplify the Laplace transform of sine at, that is equal to a over s squared plus a squared. Then we take the derivative of this quotient. It becomes like this. When we simplify the numerator, it becomes negative 2 times a times s. Then the negative outside and the negative in the numerator becomes positive. So we simplify it into this final answer. Example 2, find Laplace transform of t squared times e raised to negative 2t. By property number 6, this Laplace transform is equal to the second derivative of Laplace transform of e raised to the negative 2t with respect to s. Then we simplify the Laplace transform of e raised to negative 2t. And the value is 1 over s plus 2. Then we take the second derivative of this function 1 over s plus 2. Let's begin with the first derivative of 1 over s plus 2. We can show that this is equal to the quantity s plus 2 that is raised to negative 1. The derivative is now negative 1 times the quantity s plus 2 raised to negative 2 times the derivative of s plus 2, which is 1. We simplify this into the negative of the quantity s plus 2 that is raised to negative 2. Then we go to the second derivative of this fraction, which is we're going to take another derivative for this function. This is now equal to positive 2 times the quantity s plus 2 that is raised to negative 3 multiplied by the derivative of s plus 2, which is 1. We simplify this further into 2 all over the quantity s plus 2 that is raised to power 3. This is the final answer. Example 3. Find the Laplace transform of t times sine square t. By property number 6, we write the L of t times sine square t is equal to the negative of the derivative of L times sine square t. We're going to use the identity that sine squared t is equal to 1 minus cosine 2t over 2. We substitute this value in here and it becomes like this. We can simplify this further by putting the constant 2 outside the Laplace transform. So it becomes negative of the 1/2 that is now outside. Then inside here is the 1 minus cosine 2t. Then we will take the Laplace transform of this 1 minus Laplace transform of cosine 2t. When we simplify this Laplace of 1, it becomes 1 over s minus Laplace of cosine 2t will be s over s squared plus 4. Then we take the derivative of each of the terms. For the 1 over s, we can show that this is s raised to negative 1. Then let us do the derivative. We have now this negative 1 times s raised to negative 2 minus, on this fraction, we will apply the quotient rule and it becomes like this. When we simplify the numerator here, we have this 4 minus s squared. Look here that we have negative 1/2 outside. We will multiply this negative 1/2 to each of the terms inside the grouping symbol. So we have now this 1 over 2s squared plus 4 minus s squared all over 2 times the square of the quantity s squared plus 4. This is now the final answer. I hope you learned something from this video. See you again next time.